Hello friends, so after studying relative velocity method, we are going to study relative velocity of points on the same link. This is the point C. We have to find the velocity of point C, which is on the same link AC and BC. So we have to find out velocity of point C. Here the velocity of point A is given, that is VA. Also velocity of point B is given, having velocity VB. Velocity of point A and B have definite magnitude and direction. So we have to find velocity of point C. First of all, we clear that velocity of point A and point B have direction which is not perpendicular to link AC and link BC respectively. That is, velocity of point A is not perpendicular to link AC and velocity of point B is not perpendicular to link BC. So these velocities are perpendicular to definite point. Assume the point O. So the velocity of point A and B are assumed as they are perpendicular to point O. Let's start. First of all, we take line parallel to VA from point O. It has a magnitude which is definite. So this is point A. Which gives velocity VA. Similarly, we take line parallel to VB from point O. It also has definite magnitude. So this is point B. If we join this point A and B, it gives velocity of point B with respect to A. The line is velocity of point B with respect to A and is perpendicular to the link AB. So it is perpendicular to link AB. So here this is velocity VB. Here our velocity triangle is complete. So now we have to find out velocity of point C. So that first of all we will take a line which is perpendicular to link AC from point A. We extend this line. Also we will take a line which is perpendicular to link BC from point B. So we will take it from point B. So this line is perpendicular to AC and it will perpendicular to BC. When this line joining together, it will give point C. So after joining point O and C, we get velocity of point C. So in this way we find out velocity of point C by relative velocity method on same link. Here if we draw arrow, it gives velocity of point C with respect to A and it will give velocity of point C with respect to B. So in this way we have to find out velocity of point C. Hello friends, let's solve the problem to find acceleration of link in 4-bar chain mechanism using graphical method. In this problem, we have to find out relative velocity and acceleration diagram. So given data is QP, which have length 62.5 mm, is equal to 0.0625 meter. QR is equal to 175 mm, is equal to 0.175 meter. RS is equal to 112.5 mm, is equal to 0.1125 meter. PS is equal to 200 mm, is equal to 0.2 meter. Angular velocity of link QP is equal to 10 radian per second. Angle QPS is equal to 60 degree. Angular velocity of RS we have to find out. Angular velocity of QR we have to find out, and also we have to find out angular acceleration of link RS and link QR. So for drawing configuration diagram, that is space diagram, we will take scale, which is 1 centimeter is equal to 20 mm. So the link PS is fixed. First we draw link PS, which has length 10 centimeter by scale. Link PS is fixed. Then angle QPS is 60 degree. So we draw angle QPS 60 degree. Then the length of link QP is given, PQ, that is 62.5 mm, and by scale it will be 62.5 divided by 20, 3.125 centimeter. So it will be here, point Q will 3.125 centimeter. Then link QR is 175 mm. From scale it will be 8.75 centimeter. So it will be 8.75. And from RS it is 112.5. From scale it will be 5.6 centimeters. So we will extend this point. So here we get point R. After joining this, PS is 200 mm, PQ is 62.5 mm, QR is 175 mm, and RS is 112.5 mm. So here velocity of QP. So So it is equal to angular velocity of QP into length QP. So it will 10 into 62.5. So it is equal 10 into 62.5. So it will 625 mm per second. So for drawing velocity diagram, first of all we will take perpendiculars to each link. Now for velocity diagram, we will take scale. 1 centimeter equals 100 mm. Let's take point PS, which is fixed point. We will take a perpendicular to link QP and it will passing from point PS, and it has a definite magnitude. It gives velocity of PQ. It has a magnitude, which is 625 divided by 100, 6.25 centimeter by degree. So this point is our point Q. Now we will take a line perpendicular to link QR, which is passing from point Q. Then we take line perpendicular to link RS, passing through the point S, that is fixed point PS. In this way we will get point R. It will velocity of link QR. It will velocity of link RS. So in this way our velocity diagram is complete. Now for angular velocity of QR. QR equals 3.5 into scale, where 3.5 is the length of VQR, so it equals 3.5 into 100, 350 mm per second. So angular velocity of QR equals velocity of QR upon length of link QR. So it will 350 upon length of QR is 175 mm. So angular velocity of QR equals 350 upon 175 2 radian per second. Similarly, for angular velocity of RS, velocity of link RS equals (4.2) into scale, where 4.2 is this length, that is VRS, that is obtained from velocity diagram. So this is our velocity diagram. Here VRS equals 4.2 into our scale is 100, so it will 420 mm per second. So now we get angular velocity of RS, which is velocity of RS into length of link RS. Sorry, it will velocity of link RS divided by length RS. So it will 420 divided by length of RS is 112.5. So it will 420 divided by 112.5. So that is 3.7 radian per second. So in this way we find out angular velocity of RS, which is 3.7 radian per second, angular velocity of QR, which is 2 radian per second. So now we have to find out angular acceleration of link RS and link QR. Gurujit, let's plot the values in chart. So length of link R in meters. So for QP it is 0.0625, QR 0.175 and RS 0.1125. Velocity of link V in meter per second. For QP 0.625, for QR 0.35, for RS 0.425. Acceleration of link QP in radial component, it will be 6.25 and having direction parallel to link QP. For QR, it will be 0.7 meter per second square and direction is parallel to link QR. For RS, it will be 1.605 and direction is parallel to link RS. Now let's draw the tangential component. For QP, it is 0 because acceleration is 0. Crank is rotating in uniform velocity, so it will be 0. For QR, magnitude is unknown. And direction is perpendicular to link QR. For RS, similarly magnitude is unknown and direction is perpendicular to link RS. Let's draw acceleration diagram. So now we are going to draw acceleration diagram. First of all, we will take PS, which is fixed point, and we draw so let's draw an acceleration diagram. First of all, we will take point PS, which is fixed point. Then we will draw a line parallel to link QP, PQ from point P. So magnitude of this line is 6.25 meter per second. So our scale is, for acceleration diagram, 1 centimeter equals 1.25 meter per second square. So from this scale we will get 6.25 upon 1.25, 5 centimeter line. So this will be 5 centimeter, and the point is Q. It will give acceleration QP. Now we will draw line parallel to link QR from point Q, which has known magnitude, which is 0.7. So it will be 0.7 divided by 1.25, 0.56. So it will be nearly there. So this point is R dash, and this gives acceleration, which is radial acceleration of link RQ. So now we draw a perpendicular to link QR, because we have to draw tangential component for RQ. So here it will give tangential acceleration for link RQ. We will extend this, then we draw a line parallel to link RS, which gives radial acceleration for RS, and the magnitude is given for this one, which is 1.605 divided by scale 1.25. So it will be 1.2. So this point is R double dash. Then we will draw perpendicular to link RS from that point, which is point R double dash, and it will tangential acceleration for RS. So in this way we get point R. After joining point RQ and PS, we will get acceleration diagram. Let's find out angular acceleration of RS. First of all, length R dash R is 6 centimeter. So tangential acceleration for RQ is 6 cm into 1.25, which is our scale. So it will be 7.5 meter per second square. Tangential component for RQ equals angular acceleration for RQ into length of link R in meters, that is for RQ. So angular acceleration for RQ equals tangential acceleration for RQ upon RQ. So angular acceleration for RQ will be 7.5 upon 0.0625, which will be 8 which will be 42.85 radian per second square. Now let's find length of R double dash R, which will be 8.2 cm. So tangential acceleration for RS is 8.2 into scale, that is 1.25. It will be 10.25 meter per second square. Now tangential component for RS is angular acceleration of RS into RS. So angular acceleration for RS is equal tangential component for RS upon RS. So it will be 10.25 upon 0.1125. So angular acceleration for RS equals to 91.1 radian per second square. So in this way we find out angular acceleration for